Now, we know how to calculate the number of units and amount of revenue for multiple products to break even. I introduced a concept yesterday, margin of safety for single product. It's also applicable here for multiple products, right? Which means that we still need to ask ourselves, how much excess revenue do we have before we change from a profitable position to a loss position? How much excess unit of sales do we have before we move from a profitable budget position to a loss position? It's still very relevant whether we are selling one product or two products. So which means we still need to be able to calculate the margin of safety. The only thing is here, we just stick to revenue and we'll be looking at the mix because there are different products involved there. So we're not going to do it for each product because we're not selling one product. We're all selling the mix of products. So our break even is going to be what we know before. So take, for instance, if you want to calculate the margin of safety in terms of the revenue, which is what you will always have to do, you're asking yourself, what is my budgeted revenue and what is my break-even revenue? What is my break-even? So let's assume that in that same scenario, the budget revenue is equals to 60,000. If we make that assumption and we need to calculate the total revenue that is in excess of break-even, then it's just going to be 60,000 minus our break-even revenue mix, which we got here. Remember, this is revenue that makes us break-even, 59,603. So that's minus 59,603. And that gives us $397. So which means that we only have $397 cushion. So if any of our cost increases by 397 and more, we would not be profitable again because we only have just $397 cushion over our break-even point. And the same way you've done it in revenue, you can be asked to do it in percentage. And if you want to do it in percentage, similar to what we did yesterday, you just divide that 397 by the budget of 60,000. And that gives 0.7%. You can see, is this good or bad? Bad? Is that bad or good?
It's bad.
Why?
That's a very low percentage of safety.
Exactly. It's really, really very low. It means that anything can happen because this is super low. And that's why margin of safety is a risk management tool. So you can see it that you are not really very safe. That's called margin of safety. How much margin do you have to safe zone? If your margin is wide, then you are really safe. But if it's very narrow, then you can move from safe position to unsafe position very easily. Very good. Same thing we can do for target profit. So you can see it's just reinforcing what you did yesterday, but in slightly different way. Because I know you can just work this out. Yeah. Instead of targeting fixed costs, now we are targeting fixed cost plus the profit. That's what it means. So the same ratio is what we're going to be using, which is contribution per sale mix. Yeah. We expect that to be the same thing as fixed cost per sale mix. So how much revenue are we going to make to achieve a particular profit? Easy. What we're saying is that Our contribution per sale mix is 0.453. And we expect that to be the same as the fixed cost per sale mix. So which means if 0.453 fixed cost is equivalent to one sale mix, one revenue mix. What we're saying is 0.453 of fixed cost is equivalent to one sale mix. Now we want to target more than fixed cost. We want to target a profit of 50,000. Then it means that what we are targeting will be 27,000 plus 50,000. And that is 77,000. So we expect that to be equivalent to how much sale mix? That will be 77,000 multiplied by 1 divided by 0.453. That's 169,000.
Right.
Yeah. So this is the revenue that will give us that 50,000 profits. You can, at your leisure or later, we can test it out. You will see it. That with that kind of revenue, you will be making a profit of 50,000. And you can also do it for break even. With break even, all you need to do is just remove the 50,000 and you will have the break even. And you can also do the same for units. Can you do the same for units? Tell me, how many units do you have to produce to make profit of 50,000? Now we know the revenue to make target profit of 50,000. Now use the same, your knowledge, what we've done the break even for units. Now we are doing more than breaking even for units. We want to make a profit of $50,000. So that's target profit. How many units of A and B? Remember, you won't work with units. You need to work with mixes first, then you convert your mixes to units. So quickly. What do you have?
I have 40,000 for A
Okay.
and B 10,000.
Okay. Okay. So always think about picking the right ratio, and you only have two ratios. Is that you are using contribution per mix or contribution per sale mix. If you are looking for revenue figure, you are using contribution per sale mix. If you are looking for units, then you are using contribution per mix. And we know that contribution per mix, we already have it 7.7 because we are looking for units. So we are going to be using contribution per mix. So which means this 7.7 is the fixed cost that will be equivalent to one mix. But now we are looking for just not fixed cost, but plus target profit of 50,000. So which means 77,000 total is what we are targeting. And that will be 77,000 times 1 divided by 7.7. And this is 10,000 mixes. So if the total mixes is 10,000 and we are selling ratio 4:1 for one mix, so this is one mix, then 10,000 mixes, we'll make sure that we are selling 40,000 of A and 10,000 of B. That's it. And that is the units that we have to sell in order to make this profit. If you actually quantify the revenue that this will translate to, it should give you this figure, your targeted profit, targeted revenue. And we can try it. It's price of 3 and 5, right? That's the selling price. 3 times 40K, that's 120K. 5 times 10K, that's 50K. And that gives us total revenue of how much? 170K. That is exactly what you have here. This is 170K. So sometimes when you are doing the calculation as well, you can just quickly do some back-end check to just see what you are getting. Does it make sense? Like, okay, so that is the calculation that we have to do for those mixes. Now, just like we did yesterday, we move to graph. The graphs for multiple products is not as easy as the single product. And that is why we will not be doing so much graphing, because there's not so much you can draw, because there will be too many lines, because they have different products. So there are only two graphs that we're going to draw, and that will be your traditional PV chart, profit volume chart. Yeah, in fact, that is the only thing we're going to be drawing, because the other one, you have to be drawing so many lines. So this is what you are going to focus on for the exams, using profit volume chart, which is the first chart I gave you yesterday. If you remember this chart that Usman spoke about when we started, that's just showing us that fixed cost is like this. Total cost will start from here, and revenue will start from here. Yeah, this is total revenue, this is total cost, and this is fixed cost. This is activity level, and this is the amount. Remember, this is a traditional profit volume chart that we looked at yesterday. And that is the same thing that will be applicable here. However, there are going to be two possibilities of how companies realize those products. How do they sell those products? So two possibilities, or you call it two assumptions. Remember, what we have been doing all day long is an assumption that those products will be sold at a constant mix. That is one possibility. And that was what we used throughout for the calculation. And that is the only thing you always do for calculation, constant mix. But when you are talking about graphing, you can make a second assumption if it is graphing. And the second assumption is that there's a possibility that product will be sold in order of profitability. And what does this mean? It means that the most profitable product will be sold first before the next one is sold. So which means if you are selling 4 products, you have to rank those 4 products in order of profitability. First, second, third, fourth. Then you sell the first one before you sell the second one, before you sell the third one, and finally the fourth one. Yeah. So we need to be able to plot for both scenarios, both possibilities. Yeah. So we want to draw the same traditional volume profit chart. Yeah. However, we're going to be using this question to do it. So which means the company we are looking at is selling 3 products. Selling 3 products. Do we know the mix? Let me ask you, do you think we know the mix? What's the mix from the information you have? Can you tell me the ratio? So this is another way you can have a question, and you need to be able to work out what the mix is.
2 to 4 to 3.
Exactly, 2 to 4 to 3. Do we all understand why it's 2 to 4 to 3? But ratio has to be the minimum. So what you said, Usman, is partially okay for ratios 8, ratio 6, but you can still break it down further. That's why you can't stop there. So this is actually your mix that they have given you indirectly. So you just need to know that that is the same thing as this, so that when you're doing your analysis, in case it's a calculation you have to do, then this is one mix. Because if you use 486, 486 is not one mix. That's 2 mixes. If you do 486, so which will impact on your calculation. You must make sure your ratios goes to the last possible division. Take note. Yeah, but anyway, what we're going to be doing is we want to draw a chart. This is what we want to do. We want to draw a PV chart. And I told you that for companies that sell more than one product, you cannot do so many charts. The only chart you can do is a profit volume chart, which is a traditional one, right? And in that traditional one, there are 3 lines that we normally draw, 3 lines. Yeah, the first one is total revenue. Yeah, we need the total cost line, and the final one is the fixed cost line. So these three lines we need to plot on a graph. But the question is, how do we know how to plot the graph? How do you draw a line? What do you need to do to draw any line on a graph? From what we did yesterday, what do you always need to be able to draw a full straight line on any graph? You remember? What do you need?
We need the minimum and maximum.
Fantastic. You always need 2 points, minimum and maximum. That is the same concept we're going to be using. Fantastic. Right? So which means for us to know the total revenue, we need to know minimum and we need to know the maximum for each of these guys. So let's start with revenue. What's our minimum revenue?
Zero.
Minimum 0. That is if we don't sell anything. Our minimum revenue will be 0. But if we're able to sell all our budget units, what will be our maximum revenue? That means it's going to be 4,000 times 16, 8K times 12, 6K times 12. Add all together, and we have our total revenue. So that is 16K, so 16 price multiplied by 4,000 units, plus B is sold for $12, and we budget to sell 8,000 units. C is sold for also $12, and we budget to sell 6,000 units. If we add all of that together, what do we have? Calculator.
232,000. 232,000.
Thank you. So the maximum revenue is 232,000. So for revenue, we have 0 and 232,000. Let's go for total cost. What is the minimum total cost?
It's the fixed cost, but please go over. I cannot see.
Fixed cost.
Fantastic. And how much is that?
I could not see. Like 20,000. Okay.
Thank you. So that's our minimum total cost, 20,000. Then maximum will be fixed cost plus variable cost. Yeah. And this variable cost will be the variable cost at maximum units. Yeah, which we already have. So which means we know our fixed cost to be 20,000. That is given. But we now need to get the variable cost for each product, A, B, C. And for A, what's the variable cost per unit? 6. So we multiply that by 4,000. B, 8, we multiply it by 8,000, and 10 by 6,000. So 6 times 4, 24, 64, that's 88, plus 60, that's 148. And this is 24K, this is 64K, and this is 60K. Yeah, so plus 20K. So we have 44, 108, and $168,000. So that's our maximum total cost. So we can plot it, 168K and 20K. Then we know fixed cost is fixed, and it's going to be 20K for everything. And we're good. The next thing is we need to plot. So let's try and plot. Now, let's start to plot. The easiest one to plot is always the fixed cost. So let's plot that 20,000. 20,000 will just be somewhere here, not up to 25. Yeah, so that should be somewhere here. So I'm just going to draw it line. So we have fixed cost line. Right? The next one is to do the total cost. Let's do total cost. Total cost minimum from 20 is the minimum. When there's no activity, that's fixed cost. Then when the activity is at the highest level, which means at total unit of what is that? That is 18. 4 plus 6 plus 8. That's 18 at this point. Yeah, it has to be 168. So if I trace this 18 line to where I can get 168. So this is 150. This is 175. And I need 168. So 175, 168 should just be somewhere in the middle. Remember, like I always tell you, you don't need to be super accurate. So it should be somewhere here. So we need to join those two lines, those two dots, to have our fixed cost line. So that's our fixed cost line. Sorry, total cost line. That's the total cost. Then the last one is to plot the revenue. And that is from 0, when there's no sale, to when there's 18,000 of sales, and that revenue is 232. So if I trace that up, this is 220, this is 225, and 232 will be before 250. So if I just put it somewhere in the middle here. So we need to join from 0, yeah, because that's revenue from 0. Yeah, perfect. So now, oops. Yeah, so from 0, yeah, so that's our revenue line. So we have the graphs ready. The next thing is to look for a break-even point, which is staring at us here. Yeah, if you trace that down, you can get the unit and you can get the revenue and the total cost. So for this question, what it means is that our break-even unit is equals to what? 4,000 units. And that gives total revenue equals to total cost, yeah, at break-even of $50,000. That's what the graph is telling us. Do you know what has happened here? We have plotted this graph based on one assumption, which is the first assumption. This is a constant mix. That's what we have assumed. That's the constant mix that we have assumed. Yeah. And we'll say that if you are using graph, you can make this second assumption that product will be sold in order of profitability. And that is the last thing I want us to look into.